Okay, so this next video is going to be going over the equation of a tangent line. So in the last video we talked about the difference between a secant line and a tangent line. Now a secant line, it's a little bit easier to figure out the equation, but tangent line is where we actually need calculus. Okay, so this video is going to be about how to actually figure out the equation of a tangent line. So the first thing we're going to do is we're going to go over how to find the equation of a secant line, which you guys should already know, so this should be a review. To figure out an equation of a line, you need the slope and the y-intercept. You should remember y equals mx plus b, but you have to figure out the m and the b. The x and the y can be any coordinate. Okay, so the first thing we're going to do is do it for the secant line. So y equals mx plus b. You should remember that m stands for slope, and to find the slope, you know that it's change in y over change in x. Okay, just to simplify this, I'm going to make everything in terms of x. So rather than using the y, I'm going to actually use the f of x instead. So our change in y becomes change in f of x over change in x. Okay? For this particular example, our delta f of x is going to be this f of x2 minus f of x1. Okay, it doesn't actually matter the order as long as the coordinates match up in the equation. So our delta f of x is going to look something like this over x2 minus x1. Okay, so these are just three equivalent statements for how to figure out the slope using the secant line. So we have 2 points, that's how you figure out the slope. Next we need to figure out the b. Well, since our b is related to the y and the mx in this equation, all I'm going to do is subtract mx from both sides, and our b is going to be equal to y minus mx. Okay, so I'm just going to write equals y minus mx. So you just figured out the m, you can plug that straight in here. The x and the y, you can use either one of the coordinates as long as they match. So if you're going to pick this one, make sure it's this y and this x for the equation, or vice versa, this y and this x. And you'll figure out the b. And then you can plug the m and the b into the equation, and you'll have the equation of a secant line. Now this gets a little bit more complicated when we try to figure out the equation of a tangent line. But the main reason is, and we discussed this in the last video, is tangent lines are based off 1 point rather than 2. Secant line, we have 2 points here. Tangent line is based off of 1 point. So when you actually try to do the delta y over delta x, you only have 1 point. So you would have f of x1 minus f of x1 over x1 minus x1, because it's the same point, it doesn't change at all. You'd end up with 0 over 0, which you can't do. So this will not work. Okay, so we need to figure out a way to get it to work. To figure out the slope of a tangent line, we need calculus. So what I'm going to make you guys do kind of is imagine a point that's getting infinitesimally closer to this point right here that makes up the tangent line. Remember, it's based off of 1 point, this point right here. Imagine a point that's getting infinitesimally closer to it from either side. It doesn't actually matter which side you get. So just imagine that there's a little point that's getting infinitesimally closer. I'm just going to draw it, I don't know, right here. Okay, so just imagine it's getting infinitesimally closer and closer and closer, but never actually reaching it. Okay, so hopefully that sounds familiar, infinitesimally closer. That's based on our concepts of limits. So what I'm going to do is give that point some coordinates. It's just going to be x1 plus h, and h is just going to be closer and closer to 0. Okay, so it's a little bit more than this x1, or it could be a little bit less. I just chose to do more. And the f of x, the y coordinate, is just going to be f of x1 plus h. So this is going to be our coordinate of that point right there, as h is getting closer and closer to 0. So it's getting infinitesimally closer. And I could have done the same thing on the other side. It wouldn't matter. It would still come up with the same answer. So what I'm going to do now is use this point and this point to figure out the m and the b. Okay, so again, we need our limit idea. So I'm going to start off the equation with the limit as h goes to 0 of delta y over delta x. Now since I put the y terms, both y terms in terms of x, I'm going to change this to have it say the limit as h goes to 0 of delta f of x over delta x. I'm going to break it down like I broke it down here so we have a more useful equation. the limit as h goes to 0 of, so it's delta f of x, so it's going to be this minus this. So it's going to be change in y of this y and then this y here. So I'm just going to write f of x1 plus h minus f of x1 over, now our delta x is x1 plus h minus x1. So x1 plus h minus x1. Now hopefully you could see how this simplifies on the bottom here. We have x1 minus x1. That term cancels and you end up with h at the bottom. So you end up being able to find the slope using this limit equation. Over h to find the slope at this one point. You need 2 points to make the slope, so I just made an imaginary point that's getting closer and closer to that x1. So it's only h away from it, but h is getting closer to 0. So that's where we need to use our idea of a limit. And this is why a limit is so important to calculus. So this is how you figure out the m for a tangent line. Now our b ends up being the exact same thing, because once we have the m, we can plug in the x and the y. Well, since there's only 1 point on the tangent line, x1 and f of x1, it just ends up being the same thing. B equals y minus mx. So you just plug in the x and the y after you find the m, and then you'll find the b, and then you can put it in the form of y equals mx plus b, and then you have the equation of a tangent line. If you have any questions about any of this, let me know.